Professor G.V. Rao. This is Professor Praveen, head of the
Enthramand
department.
expected? Any participants?
Sir, there are two enter, sir. There is some issue, I think. Our computer people are resolving.
Namaskaram, namaskaram. Thank you.
Namaste, sir.
Namaskaram.
Charan Reddy garu, is everything fine? Video adi baane unda?
It is fine, sir. It is fine.
Is there any issue?
Only thing is our computer center people.
Okay. Shall we have to talk to Professor Ramasudha? She is back yesterday evening. She has come back to Vizag yesterday evening. Can talk to her if it's needed.
So Praveen garu, ippudanతా ఆన్లైన్ అయినా క్లాసులు అన్నీ కూడా
ఆన్లైన్ అంటే మేము సెమిస్టర్ కి ఒక మంత్ ఎవ్రీ ఇయర్ కాంటాక్ట్ క్లాసెస్ పెడుతున్నాం సార్. So that they can complete the laboratory part of and one mid examination in contact mode. So that and online it's slightly difficult to ensure very correct way of conducting examinations. Koncham difficult avutundi. Assignments they can be easily copied or we can't be sure about it. So we thought at least one mid examination if we conduct in contact, we can differentiate between very good students and average students. So that's what we try to do. Lab conduct chesamu 3 weeks lo we try to complete almost 80% of the laboratory experiments that are in the syllabus and conduct internal lab examination. External lab examination we are conducting in contact. In fact, coming Monday nunchi we have second year and third year students. We are having final examinations along with lab examinations.
ఇప్పుడు ల్యాబ్ ఆల్సో naturally you can't increase the number of groups kada lab groups. It will remain same only.
Sir, can you please repeat it?
But the groups of the laboratory also will be same thing as normal kada. You can't increase the number of groups. I mean distance and this and that we can't really follow. Very difficult kada.
Ante to the extent we can. Ante the number of batches కొంచెం పెంచడానికి ట్రై చేస్తున్నాం కానీ స్లైట్లీ డిఫికల్ట్ సార్. ఎందుకంటే ఎక్కువ హాస్టల్స్ ని కూడా మేము ఎక్కువ టైం ని వాళ్ళని రిటైన్ చేయడం కూడా నాట్ సేఫ్ అని we are trying to do our best. There is no foolproof mechanism. Uncertainty is there everywhere. Can't help.
And many students are still staying in hostel or everybody is coming from outside only?
No, not all from hostels. And because it's a state university, there are కొంతమంది స్టూడెంట్స్ హాస్టల్స్ లో ఉంటారు, కొంతమంది డే స్కాలర్స్. మాకు డ్యూయల్ డిగ్రీ ప్రోగ్రామ్ ఒకటి ఉంది, అది ఎక్కువ డే స్కాలర్స్ ఉంటారు. సో ఇట్స్ లైక్ వీఆర్ ఏబుల్ టు మేనేజ్ బికాస్ కాంటాక్ట్ క్లాసులు పెట్టినప్పుడు కూడా ఇయర్ బ్యాచ్ వైజ్ పిలుస్తున్నాము, నాట్ ఆల్ ద ఇయర్స్ ఎట్ వన్ టైం.
ఓకే,
సెకండ్ ఇయర్ ఒకసారి వస్తారు, థర్డ్ ఇయర్ ఒక మంత్ వస్తారు, ఫోర్త్ ఇయర్ ఒక మంత్ వస్తారు, అలా డిస్ట్రిబ్యూట్ చేసాం. సో దట్ హాస్టల్స్ లో వాళ్ళని we need not have to pile up, or we need not have to ఎక్కువ మందిని ఒకే రూమ్ లో పెట్టకుండా we could manage.
Yeah, so there's no crowding, no overcrowding in the hostels.
అంటే ఫార్చునేట్లీ సో ఫార్ సో గుడ్ సార్. ఎక్కడ కూడా ఇప్పటి వరకు మాకు స్టూడెంట్స్ వైపు నుంచి కేసు వచ్చినట్టుగా అయితే ఎక్కడ లేదు సార్. విత్ ఇన్ ది డిపార్ట్మెంట్.
You're lucky. God bless you.
We are lucky. I mean, just touch wood, we are lucky. ఎగ్జామ్స్ కండక్ట్ చేసినప్పుడు కూడా 6 feet, ఇన్ఫాక్ట్ క్లాస్ లో కూడా ఆ 6 feet డిస్టెన్స్ ని మేము మెయింటైన్ చేయగలుగుతున్నాం బికాస్ ఆఫ్ మా డిపార్ట్మెంట్ కి కొంచెం పెద్ద క్లాస్ రూమ్స్ ఉన్నాయి. సో వీఆర్ ఏబుల్ టు ఆ 6 feet డిస్టెన్స్ ని మేము మెయింటైన్ చేయగలుగుతున్నాం. క్లాసుల్లో దో 30 స్టూడెంట్స్ 35 స్టూడెంట్స్ అలాగా ఒక్కొక్క రూమ్ లో పెట్టి దూరం దూరం కూర్చోబెట్టి ట్రై చేస్తున్నాం. అంటే ఇన్ స్పైట్ ఆఫ్ ఆల్ దట్ స్టూడెంట్స్ క్లాస్ లో దే మే బి ఫాలోయింగ్ ఆల్ దీస్ నార్మ్స్ బికాస్ దే ఆర్ అండర్ దిస్ స్క్రూటినీ. బట్ ఒక్కసారి క్లాస్ రూమ్ బయటకు వెళ్ళిన తర్వాత ఆన్ రోడ్స్ వాట్ దే హౌ దే మింగిల్ ఇస్ ఎనీవన్స్ గెస్.
That's a challenge, kada.
That's a challenge, but it is beyond our control. And we keep warning within the campus whenever we see people in groups, we warn them without masks. We are doing all that. All the faculty are helping us out. Everyone is taking that responsibility individually. But still, it's not possible to zero it completely.
No, it is a challenge on everyone actually. The teacher, the students, the staff, and other people associated with it. It's not one or one group. Everybody is affected. Even the cooks in the hostel, the trainers in the hostel, everybody is affected. That's the issue.
True, sir.
And students are students anyway. It's difficult to and then say don't move. It's difficult because they like meeting others, definitely.
And initial
the word challenge is really understatement actually. It's really great challenge. One of the greatest challenges I think you people administration are facing, I should say that, because anything happens naturally you feel more responsible than what that is. You feel it actually. It's not very anyway, I'm happy that things are going relatively smooth.
So far so
and,
good.
Apart from the regular load, now you are taking a short. Depending.
Praveen sir, it seems our computer people, while creating link, have fixed the option that participants can enter by invitation. That could be the issue. That's why nobody is able to join.
Okay. So what are you going to do? Are you going to talk to Professor Ramasudha or?
No. Ramasudha team is working.
Okay.
But mistake is committed while creating link. I don't know what Google people will do. I think they are contacting them.
Yeah. Probably she was out of station. She came only yesterday. Probably people missed it up.
So what we may have to do is I should give all 350 registered participant details to our center, and just like they have sent a link to Professor G.V. Rao sir now, they have to send a link to all of them, and through that only they can join now.
So how much time do you expect for this to happen?
I'll talk to them and get back to you.
Okay.
Sir, the issue is resolved, sir. Now all participants are joining, sir.
Okay. Thank you, Vamshi.
Okay, sir.
So good morning to all of you. There is a little issue which our computer center people have resolved, and that's why there is a little delay in starting the program. So we'll wait for a few more minutes so that others who have been trying since morning, they will also join. So on behalf of Department of Civil Engineering, Andhra University College of Engineering, I extend a very warm welcome to you all to this 2-week long faculty development program on shallow and deep foundations. Tejaswini, are you there? Tejaswini?
No, sir, I think madam has not yet joined.
Okay. Harika, can you ask
Yes,
Tejaswini to join?
Yeah, she already joined, sir.
Join, huh?
Yes, yes,
Okay.
yes, sir, she's there.
So we'll start the inaugural session with the prayer by Miss Manashwani, second year student of MTech Soil Mechanics and Foundation Engineering of our department. I request Tejaswani to offer the prayer.
Yes. गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणाधीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय पालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि. Thank you.
Thank you, Tejasvi. So now we'll start the inaugural session. So once again, on behalf of the Department of Civil Engineering, Andhra University College of Engineering, I invite all of you to this 2-week-long faculty development program on shallow and deep foundations. So as all of you know, we have previously organized one faculty development program on the same topic, and now we are going for the second program, and we have tried to include some new topics in this FDP compared to previous one. And though AICTE specifies separate participants for the programs, since new topics are added, we have allowed previous course participants, if they are interested, to attend, though they cannot be given certificate, and majority of them have registered to attend. That shows right to what extent they are feeling the program beneficial. We are very happy to that. I thank all our resource persons who are highly experienced and having rich field experience for having delivered such high quality lectures. So I promise all the participants that whatever 22 sessions, technical sessions that are planned in the present faculty development program will definitely update their knowledge in shallow and deep foundations, and certainly research scholars and faculty members who will be listening to the lectures will get new ideas or directions for planning their research. Apart from benefit to their UG and PG instruction, definitely they will get some insight into new areas of research. So I'm happy to inform you all that more than 350 registrations we have received. So, and we have requested the participants to join the FDP through Google Meet link, and also through YouTube live stream. Links have been provided for all the days. So I hope as the program goes on, many will be coming. I take this opportunity to thank All India Council for Technical Education for giving our department the opportunity to organize this faculty development program. And I thank our principal, Professor P.S. Srinivasarao Garu, for his continuous encouragement and support provided in organizing this event. I also thank our Vice Chancellor, Professor P.V.D. Prasad Reddy sir, and Registrar of the University for the support that is extended in organizing this event in online mode. Now I request Professor T.V. Praveen, Head of the Department of Civil Engineering, to address the participants. Please, sir.
Thank you, Professor Satyanarayana Reddy. Professor G.V. Rao, Professor Satyanarayana Reddy, delegates, good morning to you all. This is the second FDP in the series, sponsored by, in the scheme of AQIS. It's from 18 to 31st. I understand it's for 2 weeks. Earlier program happened in around January, end of January 5th interface. Department of Civil Engineering has been organizing workshops of this nature, or faculty development programs of this nature regularly, in a very regular intervals of time we organize. In fact, in January we had a similar program earlier. In February we had Urban Stormwater Management program and a 3-day program, and now again we have this. I also would like to inform the delegates that we are, the department is blessed to have extremely renowned professors as visiting positions, like Professor S. Govindarazu from Purdue University as in a visiting position, joined us since from January 1st onwards of this year, and this month we had another feather in our cap, if we can call it, because we have Professor M.R. Madhav as a distinguished visiting professor who joined with us in this department. So really the department is going to, I hope and I wish all the faculty would take this opportunity to improve their research capabilities, and through the interactions and the guidance and support of this eminent faculty who have generously accepted to be in the visiting position. Now, as discussed in the last FDP on shallow and deep foundations, we thought at that point of time, the next session in January, we thought in the next session, that is this session, we will include a few more advanced topics so that it wouldn't be very exactly the same. It would widen a little bit, and then this could include more advanced topics which could help in the research. Younger faculty who are trying to attain expertise in geotechnical engineering aspects would also improve their research capabilities, not just teaching and other aspects. So this time they have the coordinator aptly included seismic bearing capacity of soils, ground improvement techniques employed for weak soils, and then included some more complex case studies. On geotechnical failures and a bit of forensic aspects also. So this is really a well-rounded program, and I congratulate Professor Satyanarayana Reddy Garu for arranging this workshop, for organizing it extremely well organized last time, and I hope it's going to happen this time also. I also thank Professor G.V. Rao Garu for sparing his time and for involving himself in this activity. Thank you one and all. I'm sure you're going to have very fruitful 2 weeks, and it will enable and enhance your knowledge in geotechnical engineering. Thank you, Reddy Garu.
Thank you, sir, for your valuable interest to the participants. Now I invite Professor G.V. Rao sir to deliver his inaugural address to the participants. So all of you know about him. So I will not introduce Professor G.V. Rao sir to you. He has been the backbone for us in organizing this program. Along with Professor G.V. Rao, we have Professor Madhav sir also. So they are giving about 4 lectures, right, on important topics, which will be very useful and highly informative. So as the program goes on, right, you will realize the value of the presentations. So with this, I invite Professor G.V. Rao sir to address the participants.
Thank you, Professor Sachana Reddy Garu. Respected Head Department of Engineering, Andhra University, Professor Venkata Praveen Garu, and dear participants. I think some of you I know personally. I'm not so sure how many who attended last program are also joining. It will be delightful to have them again because of the addition of a few topics. And as teacher, we will not exactly talk in the same way. Sometimes the PPTs may look same, but the way we talk could be different also, because bringing out our experiences in short time is always difficult. At the outset, what I wanted to really communicate to you is that this topic is chosen is one of the most important things in the area of civil engineering, not only just civil engineering, in civil engineering itself. Because every structure needs a foundation. Every structure obviously has to be on the ground. And this subject deals with it now. And I think Professor Madhav has got his byline on all the, at least he used to have his byline on all the emails that the solid mechanics is a science and foundation is an art. Now, it doesn't necessarily mean that we are going to have different kinds of foundations, but the application of the principles which we know have to be in relation to with respect to the conditions, both the boundary conditions and the water table conditions, and many things are going to be involved in this now. So in this, the understanding of the soil is, I think, the most important. Obviously, in a place like even Visakhapatnam, we know that the hilly region, then actually there is beach now, there is offshore work which is going on, and you go 100 kilometers towards south, naturally we have black cotton soils. And though we talk of the principles, we ought to realize that it is not just the calculation of bearing capacity and the settlement as per Terzaghi's fundamentals. That is just a beginning actually. The application is much more wider because these days the space becomes a constraint now. So wherever we were having earlier probably single story or double story buildings, now we have multi-story buildings. And these buildings are coming next door to existing buildings now. So such problems are coming so often actually that obviously distress is coming into various situations now. This distress, which was not called for earlier, is becoming important. Now in this, I have a byline myself also. We all have this KYC from the banks, know your customer. I think most important thing is that we should know our soil, KYS. So unless you understand the soil around and the experience around, naturally, you will not be a successful geotechnical engineer. So knowing the fundamentals through our books is all right. But then what is happening is, unfortunately, it may not happen every place now. But what's happening is the emphasis is on always, all the teaching and the so-called textbooks we follow is on equations and how to solve them, how to interpret, how to solve it this way, that way. But then what is happening is that the application, where from these equations come now? What are the limitations that are going to be there now? Do they really apply in a blind way to that situation? Is something an art. This is what we are trying to inculcate among you. It is not just recap of the equations and things like this now. What are the salient issues which are going to happen now? With so much emphasis on space, so much emphasis on habitat, so much emphasis on using the earlier residential areas into commercial areas now. That means, earlier we had, as I said, single double story buildings now. Some of them become multi-story buildings, complexes which are there now. They actually generate, I think, problems which we never thought of actually. And I'm also happy that this time we also have some topics on rock mechanics also, which is most important. I was telling in the last FDP also in the beginning that I stay for the last 15 years in Hyderabad. And I understand that because I was not there at the foundation distribution, my engineer told me that, sir, your building is, it's a small building, obviously. Total plinth area could be some 1,500 square foot. But then what he says told me, sir, your building is actually on three corners is on rock, solid rock. One corner, of course, is on soil now. Now, does our routine calculations are sufficient for doing this kind of work now? As my engineer use something different solution actually, and also we have this boundary soil, we have lateritic material, and issues are going to be of a different kind than just coming out of the basic equations. Equations give you something. Laboratory values also give you some typical properties for use now. But the interpretation of that now, where from what kind of parameters are going to pick up from a number of boreholes. For example, in some cases, in big projects now, we have done say 100 boreholes now. How do you pick up the data for that now? Because the structures that are going to come could be residential structures, could be as a multi-story structures, could be offices, could be abutment of a bridge or something like that. It could be, of course, many things which are there. So when we start doing this shallow and deep foundations now, we are just beginning the exercise. It's just the beginning. It's not the end now. That's why we emphasize on the basic knowledge which is required and then how to apply it in different conditions now. And I will also appreciate interaction actually. Last time also I should say, kind of disappointed because the interaction from the participants was not as expected. And particularly those of you who attended the last program, I think should take initiative and ask for clarifications or sometimes in a brief time share their experience also because, it's a question of knowledge gathering. Collective knowledge is always going to be more useful. So I personally would not want to have only a monotone, like I'm talking and you're listening. I would like to listen to each and every one of you. And naturally, as time progresses, we can allot some time also. I can finish my lecture, let's say 50 minutes before, so to interact now, provided you show interest now. Otherwise, of course, we'll be, we are teachers, we talk and talk and talk. So last thing I want to say is that apart from the so-called textbooks we are following now, there are a lot of fundamentals given out by earlier books. We have Sauer's book, we have, let us say, Leonard's, we have, of course, Bowles, which are sometimes using now. Even Bowles is going to be more mathematical, basically. But then, if you see the old books like Taylor, or of course, our classical book on soil mechanics by Carl Terzaghi, and revised, of course, updated. So the point is that unless you go through those previous books now, which are giving us an idea of how come these equations are becoming valid now, how come where these weaknesses of these are going to be there, where to change these parameters now, and which equations you are going to use are more towards the reality, let us say, the whole truth now. And unless you understand these aspects, obviously, just repeating our equations is naturally not going to help because these are available now. And ultimately, one last thing I would like to say is that, I joined IIT Delhi as a faculty in 1975. So for the first few years, naturally, I was, of course, guided by our senior colleagues, Professor Ramamurthy and Professor Gulati. And they used to say that, okay, take the parameter like this, do this, and we used to give a report. Okay, and it used to take 6 months for us, even a residential area, small area, 1 acre, they were, the Delhi Development Authority was giving us some, giving the land actually for 60, residential areas, 60 residential areas. They were giving 1 acre now. So some 3-4 boreholes were done, or half a dozen were done, and we are taking 3 to 4 months now. Today, that time is not available to us. That is one of the most important things because time is in essence also. Now, if in that time we are unable to do proper testing, naturally we have to know the limitations of this now. And also we should try to say what is the practice around the place. I mean, what kind of foundations which work, what kind of foundations which are not worked, let us say, or what are the improvements we can try to do that now. So I'm not a politician, but I think in this case we ought to really collect together. All of us together now, we belong to different districts, we belong to different institutions, we belong to different parts of the country. I think there's nowhere in the country we have basically a kind of, you can say, document which says, okay, in Black and Soil, this is what works. In this area, in Andhra University area like this, it works like this. Or in Kakinada, it's like this now. Because the coastal structures, the other kinds of things which are there, there's no, what you can say that there's no record of these things now. That means the common man which is doing his normal work now, he has got no knowledge except depending on Mesri or the contractor. Now, what our contractor says is best. Is that what we're going to depend on the contractor, or we want to use our common sense in trying to develop even simple systems of testing such that our foundations are going to be definitely stable and then also economic now. Now, when once you depend upon such kind of just experience only without the basic theory, what's going to happen is they will not be economic anymore. They will be advantages to the particular system, but then they are not going to survive in the long term because we whenever we construct more structures, naturally even 10% economy means a lot of money actually. The last thing I want to tell you is that I think the government of India has actually done a survey of all the projects, major projects, of course, which are languishing, maybe for 10 years, maybe 5 years, and maybe 2 years, maybe longer than that also. The point they were trying to say is that these are languishing partly, more than 50-60% is because of geological surprises. In the government of India, there are no geotechnical surprises, there is a geological surprise. So that means now the investigation which is being done was not so thorough that there is time overruns. Obviously, when time overruns there, cost overruns now. So again, I know that the fundamentals are going to be most important for us now. This is what we spend some time, but you should not depend upon the video or the PPT only. You should also use your basic local experience. You should also go back and study what the researchers, why they led to these equations. I think then only whatever Professor Reddy is, Sachana Reddy is doing is going to be useful because, we know that it's a pandemic time. All of us are stressed in many ways now, and you are going to spend so much time. But Professor Reddy has to sit every day actually along with us to see the things are going on well. And I appreciate the efforts in Andhra University because this is the third event he's doing himself also. The conference IGC 20 just done in December, and then in January end I think we had January end or beginning of February we had the FDP 1, now FDP 2. So it is not a small thing now. We should understand the sacrifice the Andhra University and the professors are doing for the benefit of everybody. I think I do appreciate wholeheartedly the efforts, and that's why it's a pleasure to join with them. Whenever I say, sir, come over here or give a lecture, it's always a pleasure to me. And naturally, I enjoy these things now. I enjoy the interaction. And once again, I wish the entire event a great success. And please make best use of this event actually. And I think, in my opinion, this interaction should continue actually. I think that is where the value of the program is going to be. Thank you then. Wishing you all the best. Thank you, Professor Reddy garu, Sachana Reddy garu. Thank you.
Thank you very much, sir, for highlighting the significance of the faculty development program. The subject of shallow and deep foundations, as you mentioned, is very important because engineers have to live with the soil that is available in the given site. They should have the latest knowledge and the various types of foundations which they can use in the prevailing conditions. And sometimes even in soils with poor bearing capacity also, without resorting to deep foundations, by adopting ground improvement techniques and by using reinforced soil beds, we will be able to still go for shallow foundations. So we will be covering reinforced soil bed to support footings of medium to high bearing capacity in prevailing soils of poor bearing capacity. So all these issues will be covered in this program. So thank you very much, sir. Before we start our technical session, I would like to give some announcement to the participants. As per AICTE requirement, 80% of attendance is required for claiming a participation certificate, and apart from that, at the end of the program, a test will be conducted, and participants have to score 60% of the marks in the test. Right, that is a requirement I am telling. So attendance also will be compiling day-wise, and we need to submit it to AICTE. So I request the participants to attend the sessions regularly to the maximum extent. Because of busy schedules, you may be missing 1 or 2 sessions. That's okay. That's why AICTE has also given, right? It is telling only 80%, not 100%. So the more the sessions you attend, right, the more will be the knowledge will be acquiring. I hope, right, once you go through the sessions, you won't feel like missing. Even if you miss also, YouTube links are there, right? You can listen to the lectures, right, once your right schedule works are over. So with this, we'll move to our technical session. So we'll have the first lecture by Professor G.V. Rao. He will be delivering his talk on types of shallow and deep foundations, and for choosing a particular type of foundation in a given soil condition, we should have thorough knowledge of subsoil conditions. So that's why geotechnical investigation plays a vital role in whatever foundation design and subsequent constructions we will be making. The stability of structure mainly depends on how exactly the site investigation is done. So realizing the importance, right? So we'll start with geotechnical investigation and soil testing. So before Professor G.V. Rao delivers his lecture, though majority of you know Professor G.V. Rao sir, but as a formality, I'll introduce Professor G.V. Rao to you. Dr. G.V. Rao had a distinguished career from 1975 to 2007 at IIT Delhi by serving as a professor and head of the Department of Civil Engineering. And he has also served as Dean of Students. He has guided 24 PhDs and over 100 MTech theses. And he has published more than 200 research papers in repeated national and international journals. He developed and initiated the very first geosynthetics laboratory in the country, and the first master's program in transportation engineering at IIT Delhi. He voluntarily resigned from IIT Delhi in the year 2007, and subsequently he served Osmania University as an honorary visiting professor from 2007 to 2012. During the period 2010 to 13, he served as an independent director, Ircon International Limited, Ministry of Railways. Since January 2016, he is serving as visiting professor in civil engineering at IIT Gandhinagar. Professor Rao is a fellow of the Institution of Engineers India, fellow of Indian National Academy of Engineering, and an honorary fellow of Indian Geotechnical Society. Currently, he chairs the Bureau of Indian Standards panel to draft a code of practice on geosynthetic reinforced soil structures. He is the convener of IRC H4 subgroup on use of marginal and waste materials in highway structures. He is a recipient of many awards of the International Geosynthetic Society, Indian Geotechnical Society, and the CBIP. He was recognized by the Institution of Engineers India as an eminent engineering person and by the Dr. K.L. Rao Memorial Lecture Award for the year 2015. He has delivered the Emil Arvind Memorial Award Lecture, New Delhi in 2019, and Professor N.V. R.L.N. Rao Endowment Award Lecture at Institution of Engineers India at Hyderabad in 2019. Over the years, he was involved with many institutions such as NHAI, NTPC, NHPC, Gujarat Government Water Resources Division and R&B, L&T Geostructures Mega Engineering, Jaipur Development Authority, Vidarbha Water Resources Corporation, Nagpur, and Geosynthetic Industry. He authored Airport Engineering, Principles of Transportation Highway Engineering, textbooks published by Tata McGraw-Hill, New Delhi, and he has co-authored highway testing, highway material testing and quality control, published by IK Publishers, New Delhi. His first book on engineering with geosynthetics, published by Tata McGraw-Hill, New Delhi, in the year 1990, has received international recognition through NHI, FHWA, USA. So this book was very popular. So in fact, when we were doing MTech during 1990s, we used to refer the book. That was the best book, I can say, available in the area of geosynthetics and geosynthetic soil structures. He has documented his experiences through many books and co-authored with renowned experts and practicing engineers on various aspects of geosynthetic applications, including geosynthetic testing, landfills, erosion control, and natural fiber geotextiles. He has organized a large number of training programs and workshops to promote geosynthetic technology in the country. Professor Rao is currently the chairman of Geosynthetics Technology Advisory Services Jaipur, and he is head of Geosynthetics Division and advisor R&D, Landmark Material Testing and Research Laboratory Jaipur, the only NABL accredited laboratory in India for geosynthetic for 410, right, numbers of geosynthetic tests. So I can say he is an authority on geosynthetics and reinforced soil structures. So we are very fortunate to have him with us to deliver lectures on important topics pertaining to this FTP program. So with this introduction, I invite Professor G.V. Rao sir to deliver his lecture. Please, sir.
Thank you for your long introduction about me. I think this is actually not required in the sense that we are not going to use the general prescription here given in the present context, because we are going to fundamentals and application actually.
But
And
still, I thought youngsters are there many. They should know that you have made a lot of contribution in the area of geosynthetics and reinforced soil structures.
yeah, thank you very much. It's a pleasure to hear you. Up to what time we should continue? 10:30 or more?
10:30, a little more, 10 minutes.
Yeah, okay.
Because we are delayed.
Yeah.
10 minutes. We can.
Give me a few minutes more. I will try to do, and some topics we will cover tomorrow.
Okay.
So, friends, we are talking of foundations. Let me just. Is my screen visible? Hello?
No, sir, it is not visible. Again, you have to share it.
Hey, what happened? Okay, go back.
Yes, sir, now it is visible.
Okay, thank you. So, friends, the topic we are beginning the short course is, of course, the most important topic, that is the investigation, the geotechnical investigation, as we call it. It's always my practice to remember the forefathers who brought us independence, who worked for us, and we joined him in all the facets of contribution to the country. And one of the important statements I recollect is, an ounce of practice is worth more than tons of preaching. So what we're going to talk really is the practice of geoengineering, and obviously the practice on what we understand about Mother Earth in a way. So in the beginning, most institutions were having a postgraduate program on what we call as soil mechanics and foundation engineering. And slowly, these two names, I did my master's in soil mechanics and foundation engineering, what we call as MFE. And subsequently, the name is changed to geological engineering. Now, I don't understand what is the difference between these two things. Is it a shorter form of this assessment of heat? That, okay, instead of 4 words, we'll make 2 words only? Or is it more than that? So for the young friends now, we should realize that we have included, obviously, the engineering geology, the basis of our soils and rocks, actually, the engineering part of it, and of course, rock mechanics. And if you go through the International Society, naturally they include also avalanches, snow mechanics, and many things which are there now. It deals comprehensively with the aspects of soil mechanics, you can say. But then soil is not always there everywhere. I already told you that even in Hyderabad, many buildings could be partly on soil, partly on rock now, maybe partly on boulders also. So we need to understand together the foundation materials to be able to design successful foundations. So for this, I mentioned we need a background of geology, engineering geology, to provide a brief geological description of the project area, provide a description of the hydrogeology setting, and describe the characteristics of the soils very, very briefly, and then obviously describe the characteristics of the rock. And we ought to realize that in a typical geological model now, obviously, in a typical geological model, we ought to know where we are actually, where our project area, our area is really standing. Is it on the top of a hill or hill area, mountains and things like this now? Is it at the bottom, let's say in a valley kind of thing? Is it near the sea, or is it near a river? Is it near any pond or something like that now? And because the formations of these soils and rocks depends upon the geological history, obviously. So we ought to know where we are actually, in the broad sense to begin with now. Particularly, this is true with obviously new projects which are going to do in the Himalayan region or in the region now, because we are entering into many kind of structures in areas wherein we didn't venture to go. So what are the deliverables in this case we are going to have? In a broad sense now, we are going to get a geological cross-section, the plan views, the bore logs, and then obviously the soil and rock testing data. So this is what we are going to get by investigation now. And we are referring, of course, to the soil investigation. Rock, of course, we are going to have a lecture by Professor Kesrao, but may not be in such great detail. Now, because he is only just going to give one lecture. So what we need to understand, of course, is the materials we are talking of, the earth materials we are talking of, are distinguished totally from the engineering materials that the process of design requires detailed knowledge of their mechanical behavior, both in terms of space and time, which is very important actually, space and time. This knowledge is important in many stages of planning, design and construction. This is very important for us to understand. Not only just planning, in actual design we are interested in doing this, learning about this, and also in what way it's going to be affected by construction also. For example, we may design a successful design basically for a foundation. Let us say taking care of the water table. It's a very simple assignment to total problem now. Because in bearing capacity you do the water table correction and this. But then if the water table is near the foundation area, foundation depth now, how the construction is going to happen now? Maybe it requires dewatering. Maybe it requires in some way in which we can take out the water. Maybe we have to construct a bund or something. All these things actually may influence maybe the design itself, and eventually it may also delay the construction, and it also may be costlier also. So we ought to be aware of the geological hazards which are there, and selection of the excavation method, and also stability. Of course, if you are going to use this soil for something else, construct material, and analysis of deformation stability. And what this means is that now we are not only concerned with our own building, but then we are concerned with the total stability area. And that's why we have a lot of slow failures, a lot of landslides which are occurring in all the cities which are actually in the hill regions now, because the overall deformations are not taken care of, overall stability is not taken care of, only individual building is taken care of now. So this is in totality what is we are required to. If you try to look at, we're not going to go back to all the history of all them now, but what we have to remember, of course, is we are considering a combination of mineral particles and then they are discrete particles, and then they are not bonded together. They are free to move relatively among themselves. This is what makes actually soil mechanics different. And obviously, we know that they are all coming, the soils are being formed by weathering of rocks actually. And by this weathering now, it may be causing disintegration. It may be also chemical disintegration actually. Okay. So we mean that actually both chemical change can occur and also particle size variation can occur also. And obviously, we also know that from basics of geology that sometimes from the same soils glued together, we have sandstone, we have shale and things like this. We have many examples of this now. Now, this we ought to know ourselves based upon the area. For example, recently asked one of the experienced researcher, where do you belong to? He said, oh, I belong to Kadapa. Can you tell me what is the kind of soil? Sorry, sir, I don't know. That means, that KYS, know your soil is not there at all. The basic principle is not there at all. So the common assumption, of course, which we are making in all our discussions, in all our analysis, is that the mechanical behavior is coming out because assumptions are making now. There is a homogeneous soil, it is continuous and isotropic. But then we know that the natural soils, both soils and rocks, are much more complex than this now. And obviously, they could be heterogeneous, they could be discontinuous, they could be also anisotropic. Very rarely in our teaching, we consider all of them. We just assume that the material is always like this. So that is what we have to keep in mind. Because what is the limitation of the assumptions in the practice is what we have to remember. So that is something which we have to tell the students very clearly. Now, when you're looking at the classical definition by our father of soil mechanics, Al-Razagi, so it is application of the laws of mechanics and hydraulics to engineering problems dealing with the sediments and other unconsolidated accumulations of solid particles. What do you mean by this now? When you say soil mechanics, it's not only just referring to soil particles, it's referring to naturally mechanics of particulate material and then hydraulics actually. And also relates to the way in which they have been formed. Now, all of them have to come in our testing. All of them have to come in observation of success and failure of foundations. And what he says, of course, is Arthur Casagrande has got a very classical statement. Few men in a lifetime exerted an influence on their profession to compare with that of Carl Razagi on civil engineering and engineering geology. You see, we look at Carl Razagi as father of soil mechanics, but he says the entire civil engineering and also engineering geology. Actually, the knowledge he has had on engineering geology has got a tremendous influence on soil mechanics actually. Once you go through that, the variety, of course, is a Rangoli anyway, but then the variety of soils and rocks is almost infinite, not just by the color, but then by the properties and by the depth and the variation with respect to space and time and things like this. So in actual situation, our soils are like this now. That means there are some kind of layers at the top, maybe something else at the bottom now, and thickness at a given point, at a given location is also varying now. And if you got a large foundation, let us say, on these things now, imagine that this in the structure which is, let us say, placed at a given depth now, foundation is going to experience the behavior of all these soils and rocks below that actually. So if you just take these two boreholes now, obviously the thickness of the layers are very different now. And if you go beyond this, obviously one layer is missing actually. So if you just had a one borehole here, another borehole here, obviously we know that this particular layer is missing actually. So the point we are trying to say is that now we ought to do the investigation as absolutely perfectly, as near perfect as possible, assuming the not only just the behavior of the foundation just below the column, but also the overall stability. We'll come to this when we are trying to have the location of these boreholes also. Of course, we know it's common knowledge that we use it actually as a building material. We use soils as building materials, and then we are looking at actually structure built on the rock or soil actually, and also in the rock. But we are emphasizing, of course, foundation. That means it's something which is built on the rock or soil. So from a basic viewpoint now, we ought to know the properties, the strength and volume change behavior and things like this, we ought to know. But then what is more important is what was the pre-existing state? We call it in soil mechanics, obviously, as a degree of consolidation, as let's say, over-consolidated soils, or under-consolidated soils, and non-consolidated soils. Or, of course, they are also in rock mechanics, we talk of the stress history of the rock actually, what is the pre-stress which is there now, and how they are related to our behavior, which are the structure we made now. So these actually become today quite complex, and also importance has to be given to understanding these issues in a design. So when you talk of shallow foundation, obviously what we are trying to do, we are trying to just build the structure, build the foundation structure very near the ground by transferring the building loads to underlying ground almost near the surface of the ground itself. And of course, if it is a firm ground, it's all right. And there is no worry at all for us, that we know by common sense. And if the topsoil is weak, obviously, we are trying to transfer these surface loads of the columns actually to a stronger soil, actually. Stronger soil or a rock, whatever it is now. So once we are resting the columns with foundations near the surface, naturally we are calling as shallow foundations. And this depth could be 3 meters actually. And then of course, if you are forced to transfer this now, if the soil is weak due to many reasons, we are forced to transfer it to deeper depths now, maybe sometimes resting on bedrock, or maybe sometimes supported by only friction of the soil, maybe of granular layers and things like this now. So this is important for us, that if soil is weak or the loads are heavy, naturally we are forced to go down to deeper depths of the foundation. Now, what is making this soil so complex? Why we are just doing a master's program on this itself now? Why we are taking soil properties as one course or 2 courses? And sometimes, investigation is one particular subject actually. Now, why it is so important for us to understand this in such great depth? Why we can't finish my topic in 1 hour itself? Because we are just going to give you an overview of that now. We are not going to replace all the testing on soil and rock and everything else in 1.5 hours now, or including drilling, boring, sampling, field testing. All of them are not going to be there. Can't be covered. I'm just going to give an overview, very broad overview of what is important for us to realize actually. The realization comes in because our problems which we are having are actually statically indeterminate. That means unless we, even the things like earth pressure now, unless the wall starts moving this way or that way, away from the structure or towards structure now, we will not be able to reach the limit equilibrium state of active case or passive case. So that movement is required for it to attain that state actually. If no movement is there, it's a different state of affairs. So the other important thing which we are going to look into is that natural deposits possess what we call as 5 complete characteristics. Of course, we know today very easily that soil does not linear or unique sustained relationship, and this is changed because of the control or of the behavior is a function of pressure, time, and environment. And of course, we know that soil at every location is different, both laterally and also vertically. Every even a few, maybe tens of meters, it will be changing actually because the natural deposit now. So the one thing which is going to be most important for us to realize is that in nearly all cases, the mass of the soil involved is underground and cannot be seen entirely. I will just stop here and then tell you. Now, for example, we are going to use 1 ton of or 1 truckload of steel, let us say. It's possible for us to inspect at least, visually see the entire steel. Maybe you can take a sample out of the worst looking kind of thing. If you think of ordering, let's say, tons and tons of cement also, it is theoretically possible for us to investigate each and every bag also. Though we may not do it now, we take a sample only, but then it can be inspected, it is possible. But this, of course, is not possible in the case of soils, because the very act of taking a sample is going to be disturbing the situation now. And also what we are going to do, we are going to evaluate on the basis of small samples only, very, very tiny, of which I will indicate what is the tininess which is going to be there. That is also because the soils are naturally very sensitive to disturbance, and thus whatever we are going to measure in laboratory is definitely maybe very near, but not the same as that of the in situ soil without disturbance. Now for this, as I mentioned, whatever we do, investigation, testing and all, we look into standards, usually the codes of practice which are there now, and we know that there is a good old document, code of practice for substantive investigation for foundations, followed by, of course, testing methodologies for method of test for each and every kind of thing now. But this is almost like a Bible, because in India we have to follow this now. There are many revisions of this now. ISO 1892 something is there. So it is interesting for us. Those of you simply, what you call, learned about the name only is not sufficient. You have to go through each and every page of it, each and every word of it. because that is going to give you in-depth understanding of this. They are very well written in the old days actually. People have taken a lot of time in preparing these codes. Revised year 1985, maybe under revision would have taken place. And then today there are many good books actually, which are, these two are, I should say, freely downloadable also. So very good books are come on site investigation, and all our classical books on solid mechanics obviously have given a lot of information. But one base document which you always use, like a Bible, is of course a document prepared in 1949 actually, which is called Subsurface Exploration and Sampling of Soils for Swinging Purposes, published by the US Army Corps of Engineers, almost adopted by the then Indian Society of Solid Mechanics Foundation Engineering, which is authored by, name of course I forgot to mention here, by Mr. Horslev, H-V-O-R-S-L-E-V. And this is like a Bible, that means including rock, including testing on rock, including drilling, boring, sampling, testing, and also offshore work, many things which are trying to do, just a follow-up of that only. So this is like a Bible. I don't know whether it is available in soft copy or not, but this is available to you. One should go through this. And of course, this is also available to you these days, download, free downloadable now. So as per Clayton, the first book I mentioned, the site investigation can be defined in many different ways. Site investigation, obviously we mean geotechnical site investigation or geological investigation, is the process by which geological, geotechnical, and other relevant information which might affect the construction or performance of engineering or building project. Mind you, which might affect the construction or performance. Now, very often we are ignoring the construction aspect of it. We are just looking at the equation, we are looking at only design, and we mean that the performance is going to be dictated by that only, not including the construction part of it now. So, which might affect the construction performance of a civil engineering or building project is acquired. And in fact, today, many things of environment nature also come into picture now. And so we talk of sustainability, we talk of many things now. All of these things have to come from the base knowledge of basic geological engineering, basic geological investigation. So that is something we have to remember now. It is not just drilling and boring and things like this. So the investigation, if you're looking at now, is a process, of course. We are trying to get it by drilling and boring, by field testing or in situ testing, sampling, laboratory testing, and then comparison results and validation. Now, more often than not, we don't validate actually. More often than not, when we are involved in a big project now, we all get reports from some company, and they are not validated by themselves also. We find that the correlations are not are not appearing to be very distant. Very rarely we get liquid limit values for even sandy soils also. So the point is that validation is also missing, and they are mechanically compact because we got computer systems now. There's a standard format, so you just fill up this standard format. And for example, in many cases when we got investigation done for the reinforced salt walls, as being mentioned by Professor Satyanarayana Garu, the walls themselves are going to be very broad. Meters and meters. If it is a one-side approach only, the overall width of the foundation will be 8 meters. If you have a two-lane road, it could be much more than that now. So the point is that it's going in tens of meters actually, whereas the bearing capacity is calculated as though it is a normal building foundation, maybe 2 meter by 3 meter, something like this. So obviously, the values are given. We have a tendency to simply look at the conclusion made by the investigator. He is supposed to only do the investigation and give a report of properties and cross-section, things like this, not give a recommendation. Recommendations with the geological engineer, which is going to perform the actual design of structures. And before he does it now, he is going to validate the data actually. He will also going to pick up some particular values for our use now. We will go through this as we further move, how to do this. So then, apart from the usual testing which you are going to do, there are many methods today which are actually very simple also. The electromagnetic magnetic one, utility locating, seismic methods, electrical elasticity, which we mostly do in classwork also, gravity methods, and then spectral surface waves, multi-analysis actually, drones, they are all coming into picture actually. So the point we are trying to make is now, these methods make us simpler in the sense that you are able to do a broad view of the depth and width of the interproject area in a simple way. And that helps us a lot actually. For example, in the GPR, we find that we can simply go ahead with surface only without going deep now. We are still able to understand what is the kind of soils or rocks which are there, gender certification. We are also able to locate the objects, leftover servers or any other kind of old structures. We are able to see that now. and it takes very little time actually. So these things becoming, the GPR is becoming very common also. And when you want to go deeper, also do the what do you call seismic analysis naturally. SSW and MSW become very common now. And drones, of course, are going to be moving further now in areas where we can't approach. We can take measurements. I mean, we can take photographs. We can also study the photographs. It is like in the old days, aerial photogrammetry, which was very difficult for us to understand. But today, drones are actually doing whatever the aerial photogrammetry has been trying to do effectively. And in fact, even for normal crops and things like that, we are using drones so commonly, they have become very cheap also. So the point is that they become more common than what we thought earlier. And though we will not be spending much time on these things, we spend on classical things now. Classical things like field testing, the SPT, the CPT, even the things like a flat plate datometer, pressure meter, even they are not used. And unfortunately, very few investigating agencies even have NCR testing also for a soft soil. That is very unfortunate. And I mentioned the other methods actually. And the basic thing which we thought of is the same thing, no? We can always penetrate deeper by doing, and do the testing like standard penetration test, cone penetration test, and the deltometer test actually, and pressure meter test we can do at depth now. And of course, for soft soils like which occur very commonly in the near shore, in the Visakhapatnam also, we require actually vein shear. All the Port County Road, obviously, they all got very soft soils. It's very difficult for us to get a sample also. So we need to conduct these kind of testing, not simply go by only. Most commonly, we all use SPT, and as somebody says it now, it is one of the most, though we call standard penetration, it is actually often called as one of the most non-standard kind of testing. We'll see that now. So what is it we are looking at now? This particular picture, like in Telugu we say, Ramayana can be shown in 3 words also, katte kotte teche. So this is actually one slide which gives you all the elements of what we're trying to do other than SPT. So make a borehole now. We take disturbed samples at given depths now. We also have undisturbed samples actually. And the disturbed samples, of course, are disturbed samples are marked and stored and transported. And then in the disturbed samples, we of course conduct sieve analysis. We also, of course, do wet sieving, many things we try to do, organic content, and then we do the limits now. And of course, we also evaluate if it's going to be carbon, if it's going to be either carbonates or organic material. We evaluate that all that is being disturbed samples, and then of course, from the naturally the sample from the sampler now, we extrude the samples, specimens, conduct consolidation tests, direct shear tests, triaxial tests. So this is in a simple way, all of them become equally important actually. And we are going down to what depth is also important for us to understand how deep we have to do this and how many boreholes we are going to do becomes most essential for us now. So just going back on the same thing, philosophy which we thought now, somebody has done this investigation actually. What he has done, he said, I made a borehole. He assumed some kind of foundation width, let's say, placed near the surface. And then what he has done now, he said, I got a borehole 100 mm diameter, and he has taken samples of every 2 meters, 200 mm long samples, and up to 20 meters he has taken now. And that is, he thought is the influence zone actually. This is influence zone we can calculate by Boswell's method, any other method now. So what is it going to do? If you just take the volume of the samples you have taken, that means 100 mm diameter, 200 mm samples every 2 meters, he is there now. That means he's got almost 10 samples, and volume we know now. And if you consider the pressure bulb area actually, the samples are taken are only 1 over 250,000th of the stress of ground. Such a small volume of samples are going to, that too if you are doing perfect testing. So we can change this value by taking more samples and things like that, but then it is still a very, very tiny fraction of what is the soil which is stressed. That is something we would always bear in mind. And so one of the simple things is always is, of course, this is not a pit anyway, but point is that visual inspection is the best. If you are able to make a small pit now, today with JCB present now, we can always make a small pit up to a few meters definitely. We can visually see what kind of soil is there, or we can inspect at the time of going there, is water table there or not, what kind of colors, what kind of distance now, and we can also take undisturbed block samples. That is the best thing actually. In this case, for a big project, of course, they made a pit, very large pit anyway, that's a different issue. We don't make pits like this in a regular sense. But point is that when we can inspect the sun, we can take undisturbed block samples we can also locate the strata boundaries actually, but then we will not able to go to the depth required. This will be only a near surface kind of thing now. So then, of course, the number of boreholes. What is the type and size of the project? What is the budget for site investigation? In fact, what is the time available now? And it also depends upon your experience on what is the kind of variability of the soils in that region we are investigating actually. So then, if you think of a 100 meter by 100 meter project site, actually, a building site in general, putting all the buildings together, or maybe single building, assume that we got a building area of 100 by 150 meters, large one now. Now, is it sufficient actually for a multi-story shopping complex in this general area? Is it sufficient to have just at one corner, each corner, 4 boreholes? Maybe not enough because the soil profile and properties are not well defined. Now, do you want every 10 meters actually so many boreholes now? Obviously, this looks a waste. It's so much time it is going to consume, and also it's going to take you out of your budget maybe. And then maybe very crudely, yes, not only at the corners now, we'll take something at the middle also, something at the center also, and then maybe we get tile bits in between now. So we are trying to, what our good friend Ravana says, about right, just approximately right. In this case, we didn't use anything as a judgment now, and that is the way in which we are going to look at now. So once you look at the borehole location now, so for a given building like this, buildings like this now, so what is we going to do? We're going to locate it first of all in one of the highly loaded area, maybe a lift or maybe staircase that happens to be most heavily loaded area in a building basically, and then maybe if it is industrial partly, wherever the heavy machines are there now, so there definitely we are going to do it, wherein the adjacent buildings are very nearby. And also we find that if you put these boreholes, actually we can draw typical cross sections of the profile actually. All of them are going to be important. And what we have to also look at is it going to be, what is history of this area? Is it dump site now, old landslide area and settled area? All these things we have to understand by reconnaissance, by just keeping our eyes and ears open. We are able to generate information on how good the soil is. Is it dump area? Is it a old pond and things like this? So we have to be able to understand by reconnaissance basically, and then place the structure, place the outline of the structure on the ground, and then see whether we are going to get profiles or a typical cross sections actually. So that is one way we can make a preliminary plan of borehole locations. And in this case, the structure is like this. The structure is mentioned here now, like a crucifix actually. Now these are the boreholes which are normally proposed within the area. But remember this now, this area which is sloping actually, there is water body here now. Okay, in this case now, they made it a point to assess actually what is the borehole condition. I mean, what is the typical conditions of the profile away from the actual site. He has gone down and gone up also, because that is what you require for finding out the global stability. So not only the bearing capacity or settlement aspects of the buildings are going to do, but this is going to be most important. So if he says that no, I'm only going to investigate within one building or just around my building, is not sufficient, because that will not give you the properties required for doing a overall global analysis. This becomes very relevant to all of us in hill areas or sub areas like in Visakhapatnam also. So what is it we are going to look at is, we have to look at the general nature of the soil also, general nature of the soil profile around now. Maybe it's old mining area, maybe part of it is full ground actually, maybe there are openings also, like you can say channels of limestone and things like this now. And then maybe there are many places like in Surat now, we got very old sewerage lines actually. In fact, people refuse to work in some of the areas actually. So we find also aquifers now, maybe it's also leaching actually, some leacher is going to come there. And if you just do only one borehole, let us say in this area, that is not sufficient actually. Maybe you have to do number of them because of the various possibilities now. So this comes out only by doing some reconnaissance and then also looking around all the areas and then see what is it we are going to likely to get now. And so our boreholes have to be spaced closely in such a way that we ought to get the information if that is problematic area. Then there are many stories on how to do this now, and people say these are very rudimentary kind of this one now, single-story building, multi-story buildings, what is spacing now, and obviously once a single-story building is, property is not heavily loaded, so naturally spacing are far apart, multi-stories naturally closer now, highways of course it can go up to 500 meters also, dams is much closer now, and only subdivision planning it's going to be much wider now. So that is a very broad kind of spectrum. But our IS code I mentioned has given some details also about the depth of exploration also. So what is it we are going to do? If one building is or one foundation is somewhere here and another foundation is far away, and if the distance is going to be say up to 4 times the proposed width, as of now we are only investigation only. We are just very crudely guessing what is the kind of width of the foundation. So if the likely width of the foundation is going to be, if the distance between adjacent foundations is going to be A, and if this is going to be equal to about 4B approximately, then the depth of the investigation will be 1.5 times, 1.5 times the proposed width of the foundation. But if this spacing is closer now, naturally, we'll have to go to 1.5 times the length of the building, length of the foundation, not the width of the foundation. So in the same way now, if adjacent footings are very close by, naturally, we are going to go down to deeper depths now. Otherwise, we are just going to bother about one better structure only. So we have to see all around, not only in one direction, all around we have to see, and Pattern 1892 gives you very good example of that. So once you have done it now, got some data on this now, the first thing we are going to do is the classification, as we know that now, and the classification we have to really follow what is mentioned in our code of practice, particularly in the investigation. So because if you use your own terminology, for example, people start using the word loam also sometimes. Now, loam is not a word, I think, if I am correct, it's not a word which is used in soil mechanics. It's used, of course, agriculture very, very thoroughly. It means different kind of material. But we have no experience on this loam kind of thing. So, what we have to do is, of course, we have to look at the classification system now. And by looking at the particle size, we can understand what is the basic nature, different kind of observations we can make directly on looking at this. But what is more important, of course, is even by the feeling we are going to have in granular soils, the appearance, the water movement, moist condition, dry condition, we can actually guess what is likely soil which is going to be there. Is it cohesive? Is it sandy? Is it silty? We can get. So one has to just not go by the textbook kind of this one. If you really look at the total documents, let us say, we'll get more hints on how to do. These are also given very well in the classical book by Professor Bilati on soil properties. Of course, the book is a larger book, General Engineering, also authored with Professor Manoj Datta. So the point we are trying to say is that now, normally we say sandy silt or clay silt. The word silt, is coming later. And sandy silt means, some other sand word gives importance. So we propose that it should be written as silt. And if the material content of sand is going to be more than 10% or clay is more than 10%, then we should be able to say silt, sandy, clay. And if the clay happens to be very small percentage, now we should not include that. I mean, small means less than 10%, should not include the title of the classification actually. So this classification actually is important for us in many ways. People sometimes ignore this actually. They just ask for less money for all the investigators, such a small amount of money that makes meaningless, means they're not really doing the testing. But this is very informative for reasons which I'm going to mention right now. The original soils, it tells you about different physical properties, and of course, it tells us also the likely hydrologic limits range. It may tell us something about permeability, consolidation, strength, in soil condition. All of them will get some idea, not the values now. Now, this is actually given by Professor Gulati long ago. This table is very informative. For example, if you think that it is a granular soil, don't go to the top one. We'll go to the second item, which is the gravel and sand. They have similar behavior. The difference is one of degree. High permeability material. That means, you pour a bucket of water on that, it simply completely goes down. You don't see anything at all on the surface. Then the gravel, of course, is more resistant to erosion. Then well-graded mixes are obviously more stable, less permeable. Obviously, they are very strong. That means the angle of friction is going to be very high. And also, rarely we realize that if gravel is there now, the value of angle of friction can be even going up to 40, 42, 43 degrees also. Okay. In the loosest condition, even sand, good sand actually can have angle of 28 degrees. Angle of friction 28 degrees now. And another most important thing which you realize, of course, is that some people somehow that they got very, that the field engineers have a vague idea that if we are below water, I mean, if water is there, then now it's going to reduce the strength, it's going to reduce friction. No. Presence of water in voids is of little consequence. That means the sand or gravel, if it's saturated or unsaturated or dry, it makes no sense actually. That means all of them will have the same range of angle of friction. Then you go to clay. Obviously, if you touch this clay, you have to wash your hands very carefully. It may stick to your hands and things like this now. And more clay it is, naturally, it is going to be difficult for you. You require a bucket of water to really clean your hands. So it is marked by sticky nature now. And we know that it is about low permeability. That means you put a bucket of water is staying there only, you not go anywhere else. And then we know that, particularly all of us know about the blackened soil, the behavior of this clay is controlled by the mineralogy. Particularly the mudmonite is going to really change the entire behavior of the clay. And we also know now very clearly from the limits also that this clay can exist in any kind of physical condition. It may occur in the liquid condition, it may occur in the solid condition. In the liquid condition, obviously, more than the liquid limit, it's going to be fluid. And then if it is really dry, it almost becomes rock-like actually. So the behavior of this clay is subject to the water content which is going to be there. That is most important. It changes with water content highly. And of course, silt is either way, is neither good nor bad. It is definitely less pervious, and most erosions occur only in silt. For example, erosions you find in almost all the Delhi roads on embankments is a very common sight for all of us now. And it is unstable material. And I can tell you that this is the least investigated material in the country also. We have very few papers on the behavior of silt actually. And it also increases the water, actually increases the presence of potential for instability. Now, this has not been thoroughly investigated, but I think silt is a very difficult material. As I said, if the little amount of fines, finer than silt, will influence behavior of this total silt actually. Water content has got influence of that now. And erodible things means we are going to spend more money in control erosion on the river banks, on the clay bank, on the even canals also. We have to really protect these embankments actually, or cuts very clearly. On the other hand, cobbles, larger size particles, naturally they are very stable. They are very good foundation material. So the point I'm trying to say, just the classification has given you an idea of the likely problems we are going to get by the soil, and also the kind of solutions we are going to look for, and the time is going to take for improvement now. So just a few words only on SPT test now. All of us familiar with this, and we know the standards on that now. I will not get in detail of that now, but as I told, it is something which is what we call as non-standard. So it is ad hoc test, is developed for sandy soils. Mind you, developed for sandy soils, very few. Sometimes we are also calculating the values for clay also, emanating from this SPT. That is only exceptional, but then as a routine, we can't do this now. It is developed for sandy soils wherein we can't get undisturbed samples. It's also kept to other soils because when we make a borehole now, obviously, we may have different layers now, but not by design. And then, of course, it's useful because so many correlations have been there. And but actually doing, there are many errors which are going to creep up now. And of course, it also gives us, in most cases, other than underwater, it gives us some sample, disturbed sample for classification purposes. Now, I think it is Clayton who has given these slides very nicely. The SPT test as a between 1902 and 2047 is like this. Okay, odometer 1923, gasometer 23, and then again some simple tests actually, CBT in 1945, and other level testing, this building research experiment in 45. And so most of the techniques fundamentally we use are between 60 to 100 years old actually, 60 to 100 years old. That means 40s to, or 60s, 80s to present day. So they are very old. Only improvement is being made in actual measurement of pore pressure, or you can say displacement or loads and things like this. Otherwise, of course, the Bishop traction test 1944-45 developed now. In the case of SPT, he gives example of a car in 1906, and of course a Mercedes car, let us say, or a sports car in 2006 actually. But here we are exactly same. No improvement has been made. Yes, improvements have been made now, but the errors definitely creep up, and they govern these values of SPT than the actual thing now. So we are all familiar with this now. So more often than not, it's cutting shoe which plays an important role actually. And if you watch it carefully, things are not as bright as you think of it. So there are, of course, several things which are there. We have to maintain the water table now. We need a borehole support also. The drilling has to be in a proper way. And then the blow count has to be measured correctly. But then even in drilling also, we are going to measure, of course, number of blows for every 15 centimeter penetration. And we add up the last two penetrations and say that that is the measured or field value of SPT. Okay, which is corrected. I'm not going to take your corrections because all of you are familiar with that now. But the point we are going to make is the accuracy of what we are going to get depends upon, for example, this is a common thing which we are going to do. I mean, the hammer is here and it's dropped on this head actually. In some cases, it is actually pulled up carefully and says that we have that required drop height. And sometimes the weight is dropped along this actually. So this is a, we can say, it keeps the verticality of this one. So what is happening is now, in the way in which we are going to conduct the test now, the way in which we have actually driven the borehole itself and then conduct the test now is going to influence results so heavily. And it is used around the world actually. But then what we are going to look at is, we are going to get more or less continuous kind of thing. But then not only SPD test, we also need actually a sample. That means normally we alternate with SPD and then we disturb sampling by the sampler. And let us say, as per the code, we see, I think, up 20 meters is 1.5 meter spacing, and beyond that it's going to be 3 meter, and below that up to 60 meters is going to be 3 meter spacing. I mean, much more spacing, maybe 10 meters something, 6 meter spacing. The point we are trying to say is that near the surface, wherein the most shell forms are going to be there, if you have only SPD values at 1.5 meter depth and 3 meter depth now, that's not adequate. In IIT, we made a practice to, particularly if it's going to be near shallow foundations, we say that, okay, start at 0.75 meters, and then of course 1.5, then 2.25, then 3 meters. So that, we have 4 values to look at and then assess what is the correct values. So there are many corrections which are there today, and these corrections are for hammer type correction and for rod length correction, and then for sampler itself, proper or not now, that means the bearer actually, and then diameter correction factor. So all of them are going to be corrected for, and usually what we are looking at is, we are looking at a corrected value, because using that corrected value only, other than the rotor corrections we do for delta NC and whatever and word burden correction, by putting these corrections now, we are getting an absolute value. So that value, its use, I will come again. So we have all these values with us now, but what is more important for us is, more often than not, they say sample not available, it dropped actually. So we have also a conical device, you can say, wherein the sample is going to be held actually. And also, we have got a check valve here now. The check valve, is it function properly or not now? Is it oiled properly? And is the sample retained? Because sample retention becomes very important actually. And so we get data actually in all of them. And then of course, we can calculate now. So the advantage for all of them is going to be that we can obtain some sample also, some number of SPD is there, number of blows is there now. It is simple, rugged, at low cost, suitable for many soil types, can perform also in weak rocks, though it's not recommended, available worldwide. So the point, of course, is that we are only going to get disturbed sample. Very rarely people start using this sample also for traction testing also, which is not correct. So disturbed sample for index testing only. And then it's a crude number of analysis, definitely. And this is not applicable for soft clays and sills. And also high variability, and because of this uncertainty. So we have to also keep this disadvantages in mind actually, and before we only take the advantages now. So these two have to be kept together. And naturally, the corrections are already available to you, so I'm not going to spend much time on this now. And these are overburden. And then also for overburden, there are other corrections now by Bazara and all, which we use actually, though not specifically stated in the code. And the point which we are going to make is now, we make a number of boreholes, let us say. We get all this data. And then we got a structure which we are going to construct as is given left now. So now what is it? Where we are going to place the foundation now? At which depth we are going to place the foundation? That means, is it going to place here? Or is it going to be placed here? So we need to understand actually at what level we are likely to place foundation. When once you understand that, now for example, you go horizontally now, we find that the soil here and here is same, let us say sandy, but then it becomes different here, it becomes different here. And then again, if you think of placing this now, so this problem is always going to be there, because we're not looking at the change in profile at a given elevation, we're looking at where to place these foundations. Okay. So from that angle, if you think that, let us say if you are going to consider only these two, maybe we got a third one also, let us assume that this is also here now. So which value of SPD you are going to take now? That means, let us say it shows 8 here now, it shows 7 here, it shows 10 here now. Is it, what is correct now? So this has to be statistically analyzed actually horizontally, and also vertically, and then arrive at a representative value after power corrections. And because in our foundation design, we are going to use for a given depth one particular value only. Okay. Also, we know now that if the foundation size is going to be, let us say, 2 meters now, so the influencing depth is going to be obviously 1.5. So 2 meters, 3 meters is depth. So we are ignoring whatever is above now, going up 3 meters. If, for example, if our foundation width is likely to be 3 meters, naturally, we are going to be taking up to 4.5 meters now. So what is the depth effective for taking the values of the SPT is also to be important for us. And this may or may not be stated in the code very clearly, but this is something we have to remember very clearly. So we summarize here now. Compare the results along a plane of potential depth of foundation. Before that, see the table soil. Okay. Get an average N value, ignoring the maximum and minimum. Similarly, obtain average N value at subsequent depths now. Correct each value for delta and C bore bottom pressure. And consider for design the average value within the pressure bulb. Like we said, from the proposed depth of foundation to 1.5 towards B. So that is the summary. And so we are not going to use one borehole data. We are going to use multiple borehole data and then analyze like this. Unless analyze like this now, naturally, the conclusion we are going to get out of this foundation type and design is going to be inaccurate. Luckily for us now, we had been given a good table by researchers, by field people, and these are very well mentioned in the book by Bowles. All of you know this now. The advantage of this is that we are going to get the idea of the relative density of the soil, of the sand, and based upon the SPT values. Mind you, in this case, the results are going to be for, we can say, for corrected for energy of 70 actually, 70 kilo. And then we are going to get from these values now, the 5 value also and the density value also, which is going to require for us to actually design. Now, what is most important for us to realize is that now, even when the N value is going to be between the range of 7 to 15 or 8 to 20 or 10 to 25, based upon the fineness of the soil, actually, we find that this angle is going to be very high. It can go up to 34 also. That means SPT value 7 gives you 30 degrees. SPT value of 8 in medium sand is going to be 30 degrees. SPT value of 10 in coarse sand is going to give you 33 degrees actually. So we find that for lower SPT values, ranging from 3 to 9, even then also the angle of friction is going to be very high. And it also gives us range of the density also, actual density for use now. So the point is that very rarely we find in a examination report angles more than 30, even the laboratory values. But the SPT values are very high. It can range 15 to 20, 30 actually. And even then also the angle reported is always 30. As a 30 is the base. Actually, for any loose sand, 28 is the minimum. And angles always going to be 30 and more only, not 30 and less actually. You can see for this kind of sand, it can go up to coarse sand, density between 70 22 kilonewton meter cube, can go beyond 40 also, beyond 36 also, if it is medium sand. Even fine sand is going to 33. And if it is very dense sand, that means naturally the SPT values more than 40. We can see that now the values, of course, can go up to 50 degrees, the 5 values, and the density also can go up to rarely 20, 23. So this is the picture we should try to have, not that we should exactly take these values, but also we got some tables available for consistency. But as I told you, this is only as a general guide because the SPT is not meant for this. But when once you got a borehole, we have layers of sand and layers of clay. So in such cases, definitely we can use this kind of thing. And again, here also we have the same kind of thing. So N corrected 70 is the values are between 6 to 9 SPT, and you can say this QU is between 50 to 100 kPa. And if it is stiff, naturally 10 to 16, the value is going to be like this. So you find that now the values which are being shown here for the, you can say, crude correlations are much higher than you normally expect actually. Okay, that is what you should remember, but these are only for guidance. And the advantage on conducting from SPT to DCPT is very simple. We have the same kind of hammer and same kind of systems now, but instead of the regular sampler, actually we are going to use a cone. we conduct a cone. We use a cone, replace the barrel rambling with this kind of thing, and then we are going to get continuous variation of the SPT values or N values, you can say. And there are two variations of this as given by the IS codes method of test. So we can have with and without Bentonite surgery, but then we have this kind of cone actually, and in some cases it can be sacrificial also. This is a sacrificial cone actually. And when once you follow that now, we keep just only heating, give hammering from the top to bottom continuously. But what is going to happen is and not depend upon the existing correlation. So that is the basic way of doing it now. So this is simple and fast. And as I said, instead of a split sampler, it is going to use a cone only. The rest of the exactly same. And advantage, of course, is that we are not going to require any boring at all. So that's why it is quite quick and continuous. And of course, it's inexpensive. So we do, of course, typical SPT tests, standard penetration tests, but then we can do more of this now and compare with them and try to see where the values are differing things like this. So the point we are trying to look at is that yes, we conduct a test like this. Okay. And from this, we can correlate 100 things actually. Sometimes I have doubt myself also. We try from pile friction to unit weight to undrained strength to everything we are trying to get now. From the same kind of thing, from clay for something and sand for some, all these things are there. The point is that should you depend upon just one number for all of them now? I will say that no. We have to support it by actual laboratory testing. These are only indicative values which are going to do it, and only for very crude estimates for our maybe tendering or something, we can use it now. So, particularly when you got soft soil, we can use a vane shear, both in the field and of course in the laboratory. If you can get a sample now, it is pushed into the sample, pushed into the soil, and then rotated. And advantage of that, of course, is going to be we also get what we can call a cylindrical surface now. We can also get the residual value, most simple now. This is simplest test now. I don't know why many investigators actually don't have this equipment or don't use it also. But at soft soils, this is the best way of doing it now. So in case you're able to get a sample, of course, you take the sample to conduct a vane shear test in the laboratory, and this is best actually represents the undrained condition. That means something like a uniaxial compressive strength with no confinement. Okay, and so there are standards available on this now. We usually conduct for soft soils on this now. So very soft soils can be tested now. We also get the residual value and also the peak value, and of course we can also try to get the anisotropy, but not really correctly. But that's the way it is now. So what we are trying to do is that we are trying to look at and repeat what we said in the beginning, a comprehensive accumulation of information on the ground and its characteristics so as to facilitate an appropriate foundation design. That is what we are looking at now. Appropriate means that enable a practical, safe and economic construction process to be planned. That means investigation is not meant to get the soil properties only and fill it up in an equation and then say this is bearing capacity or this is allowable bearing pressure. It is also meant to be a practical, safe and economic construction process to be planned. That is something important. So most investigators obviously are silent on this. They are not meant to do this now. But our agencies actually pick up the so-called bearing capacity, etc., whatever values it is there, and then design everything based upon them. Because the investigation is going to lead to a practical and safe economic construction process. This is something very important. So just to remind you actually. So then of course, we are bothered about the effective stress conditions. We know very well, we all remember the effective stress principle. You remember that it is not a law because in quite a few cases it doesn't work also, but then most commonly we use it. We use effective stress. So this controls nearly all aspects of behavior. Now once you do that now, immediately comes into mind consolidation actually. That means when once you place additional load on the soil now, if it is a clay soil, it is going to consolidate. Now, but we should remember, not necessarily from exam viewpoint, but then this loading has to be there, I should say permanently, or for a long time, to cause consolidation. It's not going to cause by, let's say, wind loading. It's not going to be caused by, let us say, earthquake loading, seismic loading. It is going to be giving you, if statically placed now, within a clay, saturated clay, it is initially going to give rise to an excess pore water pressure. Excess pore water pressure means more than the existing normal pore water pressure, excess pore water pressure, and then it should give time to drain out the excess pore water pressure, either naturally or artificially through drains now. So when once this excess pore water pressure is going to be dissipated now, the soil actually becomes consolidated under the existing load you applied now or the foundation load, and then this builds up more strength actually. The vertical load becomes effective overburden pressure, and the soil becomes stronger because of consolidated soil. This is something very important for us to know. That soil is getting consolidated by this process now. So we'll skip this because we don't have much time. And again, you should remember that now we are measuring soil properties in a very small sample actually. Of course, everything else is known by everybody. And I find that in most colleges, we do not even demonstrate both consolidation and even triaxial. Now, that is basics for our work now. So all teachers who are attending here now should try to get this made. In fact, some of this equipment can be made right in the workshop also, or can be done out locally also. You don't have to order standard equipment. We have all these standards of making this equipment available in the BS format actually. They are free downloadable now. So they tell you what is the size and what is the width and what is the diameter, what is the smoothness, what size of the ring now, how to load it. Everything is given in detail actually. So I observe all the teachers now, if they don't have this equipment, they can get it made in their own workshops as an exercise also with the mechanical engineers, or give an order on the outside agencies, auto workshop, something like that, we can make it actually. So that is something very important for us to understand. And then the basic principle, we say that we are going to get a permanent settlement actually. And obviously the concern is going to be time dependent. So two things we are going to get from this. We know about theory, but the students we should be able to say that now we are going to get the total settlement characteristics, and also we are going to say how we are going to get how long it's going to take to consolidation occur now, how long it's going to take for 50% consolidation occur now. So all of them should be embedded into the minds of the students now, that without a consolidation test now you cannot do a foundation design. And you just don't give data to them and say that okay, calculate this on T90, this and that, and give a void ratio pressure curve actually, and say that please do exercise. No, doing exercise is not going to be sufficient. You will have to actually do the test now. Maybe it can be done as a project now. And same thing is true. Later we'll see triaxial also. Without doing this test now, you cannot do the foundation investigation. You please do not get this done by just giving some values for the CC, CV, this and that, or C dash, I dash, or CU, 5U. So those values make sense when actually do the test now. So for every batch, at least some demonstration done now, or in the worst case, you can also go to an adjacent institute where the physics is available now. You can demonstrate it now. Maybe this demonstration by video is possible, but unless you handle this sample yourselves, unless you conduct the test yourselves, you will not realize that doing consolidation test or doing a perfect consolidation drain test for measurement, it may take weeks actually. If it's going to take weeks now, how can you get result in 2 days now? Most agencies are giving results by 2-3 days actually. How can they do 2-3 days of consolidation result now? I have recently a report right from Visakhapatnam, wherein they give the consolidation data also in 3 days actually. They simply give some CC, something like that now. So do you believe that they have done the test or not actually? So this is very important, not from just teaching alone, from assessing the reports which are going to get now, from ingrilling this knowledge in the students now, they will have to be able to see this test, conduct the test, take the measurements and actually calculate, then they'll be able to understand what is the story. So from the laboratory viewpoint now, from the strength viewpoint now, we have of course standard tests which you know. I mentioned about vein shear, we just mentioned about unconfined compression test, direct shear test, and of course triaxial test. So I'm not going to say much on this actual testing, but then I will tell you that what is important for us now. The input, of course, we are going to get is vertical displacement, lateral load, and lateral displacement. Output, of course, is going to be the shear strength. Input, I mean, actually, at the end of the testing now, we are going to find out at a given normal stress, what is vertical displacement, and what is the shearing load which we are going to get now, and what is the shear displacement, shear strain actually. And of course, we do this, we try to say in classwork that it has got a preconceived failure plane. But then what we should be also mentioned is that this is all right, despite the size of the apparatus, 60 by 60 millimeters is perfectly okay for sands and for, let us say, clays. If you are going to run clays, I'm not recommending it for doing clays, but then If you're doing for place, also for demonstration, it's okay. But then if the soil is gravelly, what's it we're going to do? We have to conduct test on a much larger specimens actually. At least this must be told to students that this is only a small device to do that, to get the test done now. But for different variable soils we are going to have, we may have to do conduct test between at 30 by 30 centimeters size of the box actually. So then of course we can always draw a line, and some people assume that 0, 0 is also a point, but otherwise we can always draw a linear interpolation of all of them now. And for sands, we all know that it should be C is equal to 0, and it will give us some value of 5. So the other thing important for us to understand is going to be, if the sand, let us say, is going to be dense now, we are going to get a peak like this. We are going to get a peak like this, a higher peak now. That means higher maximum shear stress, which will also result in, of course, higher angular friction, as is seen by the table given from bowls. If the soil is loose, obviously, loose density, low density, it is going to give you a different kind of picture. It's going to give you a different kind of picture. If it is going to be medium density, it's going to give a different kind of picture. So in all the cases now, the peak is obviously, as we expect, is definitely low. But then what is important for us is that during this process of getting a peak and beyond, going to a stage now, here there is going to be volume expansion. That means the ultimate value is going to be same. The residual strength is going to be same for dense sand, for medium sand, and for loose sand also. So that, of course, people call it as a critical water condition. That means the dense sand is going to expand, dilate actually, loose sand is going to compress now. So ultimate strength which are going to get, resistance you are going to get, will be at the same critical water ratio, and will give you, that's what we said, tau CV, critical water condition now. That means all the samples now, starting from different compact conditions, is going to give you the same residual strength, because they all achieve the critical water condition. This is something to be told students very clearly. So this is of course good actually. Only thing is that we can't control the drainage conditions actually. And because of this now, obviously it becomes a test only for drained basin test basically. And you may also do an estimate with the students that you conduct a test, and then for a given sand, both the dry conditions and saturate conditions, you realize that the difference between these two is really going to be very minimal. Other thing which you are going to mention to the students, of course, is going to be the fact that this has got a rigid boundary. Okay, that means we are not going to allow the sample to dilate or move laterally. So that means a confined condition, which is not there with respect to triaxial test. In the triaxial test, we are working with a major principal stresses, principal stresses, both major and minor principal stresses. So in this case now, these measurements which you are going to do are essentially based on the principal stress criterion. Whereas in the case of direct shear, we're not doing all that now, because we're confining our edges actually. And so it becomes more or less like a K-naught condition. So a rigid boundary is going to give you usually higher angular friction than the triaxial one with a flexible boundary. And the practical engineers actually, if they got a value of 5 from triaxial test now, we assume that in the field condition of a retaining wall or something, that it will be 10% more angular, 10 to 15%. 10% is usually done. So in the case of triaxial testing, for those of you who have done the test now, what is the advantage over direct shear test now? It is advantageous because of the fact that we are able to control the drainage conditions very well actually. We will not have time to understand the entire setup now. It requires a different setup altogether. But then basically what we are going to look at is, we are going to look at the drainage conditions now. One condition is that, or maybe I start saying that now there are two stages of any triaxial test. What are the two stages now? Initially we apply the confining pressure. That means the cell pressure, let us say. And when once apply cell pressure, the major, minor, intermediate stresses are going to be the same only. It is the pressure applied on the specimen now. When once this is done now, as the second stage of the test now, we are going to apply vertical load. It's called the deviator stress actually. So for the deviator stress to be there, obviously, that is what is going to be there. So deviator stress is going to be the additional actual load now. That means vertical stress, which is major stress, is going to be the deviator stress sigma d plus sigma 3. So these are two stages of doing the test now. And so when we are looking at the kind of actual test now, in the undrained, unconsolidated test stage now, undrained means in the first stage you are applying a cell pressure and no drainage is allowed. That means all the walls are closed actually. And in the second stage also, we are not going to allow to consolidate. Obviously, when you close the wall in the beginning, in the undrained stage, first stage 1, in the stage 2 also, we are not going to allow drainage to take place. So it is, the sample is not consolidated at all. So this is called the EU kind of test. So this is essentially based upon the release of the excess pore pressure developed due to the confinement or due to application of the rivet distance. So there's no drainage now. So obviously we are measuring only the total stresses. We are not getting any pore water measurement. So it remains as a total stress kind of behavior. In the second kind of test now, we are going to allow drainage in the first stage. That means we are going to apply cell pressure now. We are going to allow the sample to consolidate it. And then the second stage of applying the lever stress or applying the normal stress is going to be undrained. So this we call as now CU. Okay, consider undrained test now. Now this test, this part of the test now, of course, during consolidation stage now, no pore water pressure because excess pore pressure generated is going to be dissipated. In the second stage of the test now, we can measure pore water pressure, in which case is normally called as CU bar test. CU bar is something with pore water pressure measurement now. In the third condition now, third way of doing the partial test was consolidated drain case. That means the first stage also we are going to do consolidation. The second stage also during application of the rivet test, we are going to do drainage to occur continuously. So we call it as a CD test now. So in a CD test now, what we should realize is going to be, it's always going to be effective conditions, effective stress conditions. The parameters are going to get will be the C prime and phi prime, effective stress strength parameters. So they know the also parameter because both are same only. In the second case, we can choose to ignore the pore water measurement. We can get the total stress conditions, total stress strength parameters. And if you also consider the pore water pressure, we can get the effective strength parameters also. That's why CU bar is very commonly used actually. Okay, in the first stage, no consolidation at all. So these have to be remembered when we're actually doing the foundation design. Okay. So this is what we are going to remember and plot this actually. I think one thing I am going to conclude today is going to be what we are going to get for EU test actually. Okay, on the horizontal scale, we got the minor principal stress sigma 3 and the vertical stress shear stress sigma minus sigma 3, which is shear stress now. So you can use a confining pressure on this. I am talking of clays. I am talking of saturated clay being tested for EU bar test. So the first test is conducted at a confining pressure of 50 kilopascals. Okay, so we get a result like this. And the second test is conducted at a confined pressure of 100 kilopascals. And I conducted third test also at 200 kilopascals. So what do you find? You find actually the circles are really same kind of circles, same diameter now. So obviously the kind of strength we are going to get in all the three conditions is going to be the same. So what is it we are going to get now? We obviously draw a common tangent now. So under this condition, this saturated clay is going to exhibit only the C value. Is going to exhibit only phi is equal to 0, and then C will be a value. Okay, that is the intercept which are going to get on the vertical scale on the y-axis. Now, if you imagine now, we are going to conduct a EU test, a UCS test, unconfined combustion test now. What is confined pressure? It is 0. So you find that it is exactly going to be the same. The circle diameter is going to be exactly the same. So whether you conduct a simple unconfined combustion test or conduct a EU test at different pressures now, for a saturated soil, we find that we are all going to get phi is equal to 0 for a saturated clay mean, and you are going to get an intercept, coefficient intercept, which is going to be the same in all the cases now. Now, this is true. Obviously, the definition was the normally consolidated saturated clay. So this is what we have to remember actually. Now, in quite a few cases from the field, we get data saying that they did conduct a test actually, but they are trying to show an envelope like this now. They are trying to show an envelope something like this. That means it has got a C value, it has got a phi value also. What does it mean now? The specimen was initially saturated. Now, before you undertook the test, before they are transported to the actual laboratory and conduct the test now, you find that this actually, the circles are of different diameter now. And then we find that this is behavior of unsaturated soil actually, or a compacted soil. So whenever for a clay, normally considered clay, they are going to examine the saturated clay. If they show a value of C and also phi, it means there's something somewhere wrong. This is something we have to remember now. Okay. So then we go back and try to understand actually the other things which are going to do. We can try to look at that now. I think time for us to see the basic is that we are using a Mohr-Coulomb model of sigma tau, that means normal stress versus shear stress, and we are going to use a linear failure envelope now which means tau f is equal to C plus sigma tan phi. So once you are trying to do that now, the shear strength actually at failure is going to be a function of C, the intercept, and then the sigma tan phi. Sigma is nominal stress, phi is this angle, the slope which are going to be here now. So you should remember that now, the C we are going to get, or phi we are going to get, is not the intrinsic cohesion or intrinsic angle of friction. It is the way you are representing the strength. The strength is represented by a shear strength actually. Shear stress failure is in shear strength. The shear stress failure is in shear strength. So it is a way of representing the strength as a linear behavior equal to C plus sigma tan. That means it's got a constant, it has got also a slope actually. This is what we have to remember now. If you don't remember this, there's always confusion that the C is going to be coupled with the clay. Only clay it has got. No, it's not like that now. It all depends upon the kind of clay we are going to think of, the kind of boundary condition we are going to think of. So this will emphasize in the next class actually, in the tomorrow session, and then move on to bearing capacity. Because the uncertainties in our design are coming because of this lack of understanding of this behavior, and also the reports which are going to come from the investigators, they are not very clear what they're trying to do, because they simply say C and phi. What are the C and phi? And why are they exhibiting the C and phi values for saturated clay when they know the water table is well above? How they are exhibiting the both C and phi actually? What kind of test they are going to do? They say traction test. So by traction test, they mean is it U, is it CU, is it CU bar, is it CD? No, nobody specifies that actually. So the point is that now they are not giving the information on this now, and later when I come to settlement, we will see that now they will only give you CCCV, but they will not give you the consolidation curve completely. In fact, as I told you, just 1 month back, I got a report from one of the agencies actually. They have actually got a what do you call, word ratio, anomalous curves actually, urban curves, and there's almost a line actually, word ratio line, EP line is line only. And still they are trying to show our consolidation. I know they know our consolidation, they are trying to show it is pre-consolidated. All right, it's a line actually. So I don't know what is this. So we have to evaluate actually ourselves what is the correct behavior, and evaluate the report also. That's why I'm trying to get into more details of this now. We'll spend tomorrow also some 15 minutes on this and go to the shallow foundation aspect of it now. So thank you for your patient hearing. I think at the juncture, I'll be happy to clarify any doubts you got. Any questions at this stage? Hello.
So thank you very much, sir. Chat box has full of appreciation for your highly informative lecture, sir. So it is a really enlightening one. And as you said, not only the field exploration that are carried out are important, how the collected samples will be tested in the laboratory is much more important. They should know under what conditions, particularly shear strength parameters need to be evaluated for a given application. So without that, if they simply use some C and phi, it will be meaningless for use in real engineering design. So people have to understand that the proper site investigation with supplemented with proper laboratory testing by a real expert is what really we need. But unfortunately, engineers, though they give a number of boreholes and soil testing scope, but they will not give time. And in a rush, if some institution says within it takes about 1 month, they go to some agency and finally they will end up with a report which does not contain any realistic useful information. So one should realize. So I hope all the participants have realized the importance of the geotechnical investigation and soil testing. Since we started late, maybe, sir, we can allow the participants to interact with you during tomorrow morning session, sir.
Yeah.
So I request the participants, if you have any questions on today's presentation, you can discuss tomorrow, because since we started late and all of you may be having some right as tasks at your organizations. So I thank Professor G.V. Rao sir for sparing his valuable time and for giving his highly informative lecture on the importance of geotechnical investigation soil testing. Thank you, sir. I thank all the participants for taking interest in this faculty development program and for their presence for the inaugural session and for this first technical session. So we'll be meeting again in the evening at 4 o'clock for the second technical session. And so there we'll have lecture by Professor Beena of Cochin University of Science and Technology. I request all the participants to join in time so that we'll be able to complete our session within the time schedules.
Okay,
So
thank you then. See you tomorrow. Thank you then. See you tomorrow.
Thank you very much, sir.
Sir, 5 minutes, sir. Sachin sir will be posting the attendance link.
Yeah. An announcement to participants. So we are posting the attendance link. Right. So I request all the participants to fill in that Google attendance form before leaving. So thank you all.
Good morning, everyone. Sir, I am Ramakrishna from Vizag. Thank you very much for this presentation. And especially as many participants are joined today as this is first seminar, I want to inform one thing, like once this all sessions are completed, we'll have an exam also to get the participation certificate. So if we involve in the lessons and we listen carefully, we can pass that exam also very easily. So don't miss any session. Thank you.
Thank you, Ramakrishna Garu, for your valuable suggestion to the co-participants. So in fact, Ramakrishna sir was with mechanical background. He attended a last time FDP, and by listening to the lectures, he secured more than 60% of the marks in the test. So that shows his commitment. Though he is into civil work, but he is with mechanical background, but still he could answer the questions which are not that much easy, So what he was telling is if you attend to the sessions regularly, it will be easy to clear the test. So thank you, Ramakrishna Garu, for your friendly advice to the co-participants.